So, all right.
Okay.
I'm sorry. Well, the other two problems, we just found the standard form, right? So that's what I was thinking. So we got this. We completed the square, right? And so now we got our standard form. From our standard form, we were able to determine that this is going to be a horizontal. Our major axis symmetry is going to be horizontal. So now we need to determine what is the center, the vertices, and the foci.
And the eccentricity.
And eccentricity. Okay, so I can erase all this stuff, right? You guys all got this? Or write it down, so we're all good with this.
What is it?
That was the complete the square one, which I spent the last video making. Alright, so now we got all this. So now, like I said, I told you we figured out since my larger number a was under my x, I'm going to use this form. X minus 4, or I'm sorry, let's just write the standard form. X minus h squared over a squared plus y minus k squared over b squared equals 1. Right? Because my larger number is under my x, so I know that's going to be my a. That's following?
Yeah.
Why does it have to equal 1?
Completely.
Oh.
So now the next thing, the center is fairly easy. The center is just going to be the opposite, 4, 3. Is going to be your h and your k. All right. But now to be able to determine your vertices, remember your vertices is going to be your vertices lie on your major axis, right? Your vertices lie on your major axis. So therefore, I'm only going to be concerned about what a is. Well, I know that a squared equals 100 per that equation. So therefore, a equals 10. Right? So we have some parabola that looks something like this. Centers at 4, 3, 1, 2, 3, 4, 1, 2, 3. Okay? And so we have some parabola that's going to look something like this. But each distance is 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? If you're adding 10 horizontally, then you're going to be subtracting 10 horizontally, right? Because it has to, your vertices and your center and your foci, they all lie on your major axis. So am I going to add this a, am I going to be adding it to the x coordinate or the y coordinate of your center to figure out where the two vertices are? The x coordinate, right? So to find my vertices, all I'm going to do is do plus and minus from the center. So if I add, so vertices would be 14, 3, and -6, 3. Does everybody understand that? Does that make sense? Because I determined that it's a horizontal. If it was vertical, we'd be plus or minusing 10 to the y coordinate of the center. No? Question?
How did you get the 6 and 3?
6 and 3. Okay, all I did was I took, I just added 10. Well, here's my center, right? My center's at 4, 3, and I determined a. Remember, this distance is 2a, right? That's what we learned, right? So that means this distance from here to here is a. So if I determined a is 10, all I did was I added 10 to the center, the x coordinate of the center. So when you have 4, 3 as your center, you add 10, you get 14, 3. When I take 4, 3 and I subtract 10, I get -6, 3. All right? Now we need to figure out our foci. And our foci, we need to understand the relationship between our A, B, and C. Chase, you almost alive with this? Oh, it's a lot. So remember, c squared equals a squared minus b squared. That's how we're going to find the distance of c for our ellipse. So we have c squared equals a squared, which is 100, minus b squared, which is 20. So we have c squared equals 80, and square root, c equals the square root of 80. And then we go ahead and take a look at this. Let me see, all right, is there anything that we can reduce the square root of 80?
It's like 8.94.
Oh, yeah.
But we want to reduce it.
just go ahead and do it. It'll take me longer to do it on paper than we.
42, 4, and 10.
Yeah, I was like.
Okay,
5,
well,
2.
we know that four works into it.
Yeah.
So
Right.
it's 2.
So it's 4.
So how many times would 4 go in there? How many times would 4 go in there?
20.
4 goes in there 20 times, right? So you could rewrite this as 4 times 20. So we could do 2 radical 20. But then, right? But then 4 goes in there again, right?
5 times.
So you could write 2 radical 4 times 5. So then we could do the same thing here. 2 times 2.
It's 4, 5.
Like that, which are 4, 5. Which we could have figured out would have been 16, 16 times 5 also gives you 80. But so there, now we determine that's our C. Well, remember, our C, just the same, is still on your major axis of symmetry. So there's your C, and there, C, your foci. So your foci, remember, are going to be inside your vertices, between your vertices and your center. So now I'm going to do the exact same thing I did with my vertices. I'm now going to do with my foci, except my foci now is 4 times radical 5. So all we do is 4 plus 4 radical 5, comma 3, and 4 minus 4 radical 5, comma 3. Just doing like I did here. Here it was easy, I had 10. I can easily combine one terms with
How
10.
do you know where to graph that?
You know.
Well, this is going to be approximation, right? And I told you guys you didn't have to worry with your graphing, but all you had to do, you're going to have to decimal and approximate for your graph.
Well, how do you add those?
It's
Would it just
about-
be like 8 square root 5?
You'd have to convert to a, nope.
Or both?
No,
Just-
they're not
just
like
leave
terms,
it?
so you can't combine them.
Okay.
You'd have to convert to decimal and find the decimal approximation. Okay, but like,
Right.
we're not worried about finding that, we're just worried about finding the center vertices and foci for the problem.
Okay.
Okay, and then the eccentricity would be
Eccentricity, forgot about that. Eccentricity,
C over A.
C over A. So all you do is you figure out your C, which is 4 over radical 5, your A, which is 10, right? And then you just reduce. Two radical 5 over 5. Yes?
What is the eccentricity?
The eccentricity is going to tell you how much your graph is kind of look like a circle or look like a really skinny oval. Okay? And really what it is it's the ratio of where your foci is between your vertices and your center. So the closer your eccentricity, is to 0, the more it's going to look like a circle. And the farther it gets out, and the larger it is, closer it is to 1, the more it looks like a oval. Okay? That's just about it.